going to teach you how to find the sum of all the zeros of this polynomial. It's really nice when we have a polynomial who has a degree of 2, meaning the biggest exponent is a 2, because you can find zeros by just plugging it into the quadratic formula or factoring it. That's where you do the 2 sets of parentheses, the opposite of FOILing. But this polynomial has a degree of 3, which is a problem. So it's not just as simple as factoring or using the quadratic formula. We can break this down into 3 main steps. The first step would be to list our potential zeros. The way that you list potential zeros is you use something called the rational zeros theorem, which is where we essentially just take factors of this last number and put them over factors of this first number. That's going to give us a whole list of numbers that could potentially be a 0. Once you have that list, you're going to test each number with synthetic division to see which number gives you a remainder of 0. Once you find the number that works, that number is going to be one of your answers or one of your zeros. And then we take our remaining polynomial from the synthetic division, and that will be a degree 2, which I mentioned earlier. Degree 2 polynomials, you can find zeros by either factoring or using the quadratic formula. But if we take a look at these 3 steps, they all seem pretty overwhelming. Potential zeros, remember I said you use the rational zeros theorem. The word theorem kind of scares us a bit. Synthetic division, because we have to test so many numbers or so many potential zeros, that's going to be really tedious. Factoring or quadratic formula could be time-consuming. So I'm going to teach you a trick to this, solving this problem, where we can avoid all 3 of these long, tedious steps. Anytime we are asked to find the sum of our zeros, we can simply use the formula opposite b over a. Now let's talk about what the a and the b represent. I'm going to talk about a first. A is the coefficient of our leading term. So the coefficient just means this number that's in front of x. To find b, we look at the term that has an exponent 1 less and take that coefficient. So in this case, this would just be our b right here. So if our formula wants us to do opposite b over a, my b term is a -5, so the opposite of -5 would be +5, and my a term was 2. So my answer is 5/2. That would have been the sum of all my zeros if I had gone through all these steps and then added up my answers.